So today we are going to solve starters 95 division 4 fifth problem, that is evacuate to moon. So the problem is given that Tesla needs to charge n cars before sending them to space. The ith car has an energy capacity of AI watt hours. So there are total n cars and each car has energy capacity of AI. Okay, there are m power outlets. The jth outlet provides a power of bj watt. So there are m power outlets from where the power will be delivered to the n cars, and each power outlets has a power of bj watt. If an outlet can charge at most one car and a car can be charged by at most one outlet, find the maximum total energy stored in all cars after h hours. So here the condition is given that at most one car is charged by one outlet, and at most one outlet can charge one car. Means from here we can conclude that for each car there is only one outlet. So it is okay. And how much energy a car can store? So we will calculate it by multiplying the time h with the power provided by the power outlet. Okay. If the multiplication is less than or equal to the energy capacity of car, then the car can hold that multiplication. Otherwise, the car can hold up the energy up to its energy capacity. So it is okay. Now just check the code. So here we have taken input of test case. Now we are given three variables n, m and h. N is number of cars, m is number of power outlets, and h is time. For how much time we have to provide the power. So we have taken input of all the three variables. Now how we will do this problem? So we will sort. Firstly, we will store the number of cars in a vector and number of power outlets in another vector. Okay, that is v1 and v2. Then we will sort both the vectors in decreasing order. So we have sorted the vector in decreasing order, and then we will check for each index. That is, for first car we will deliver the power from first outlet. For second car we will deliver the power from second outlet. Okay, and how will we store the energy? If the multiplication of time and energy provided by the power outlet is greater than the energy capacity of car, then we will store the energy capacity of car. Otherwise, if the multiplication of time and multiplication of power from the power outlet is less than the energy capacity of car, then a car can hold only that much energy which is equal to multiplication, or which is equal to the product. So yeah, it is okay. So we have declared two vectors v1 and v2. In first vector we have taken input for the number of cars, and in second vector we have taken input of the power outlets with multiplication of the time. That is, I have multiplied time with the power delivery and stored in the second vector, so that we can directly compare second vector with the first vector. Okay, now we will sort both the vectors in decreasing order. So we have sorted. This is the syntax for sorting the vector and for sorting it in decreasing order, we will make one boolean function, this one, to sort it in decreasing order. That is, if two if two variables are if two variables are supplied to this boolean function, then it will return firstly the greater one and then the lesser one. So it will sort our vector in decreasing order. Now, up to how much we will check the means up to how much we have to calculate the sum, that is the minimum of n and m. Means if number of cars are less than the number of power outlets, then we have to go up to number of cars, and if we have number of power outlets less than number of car, then we will go up to number of power outlets. So I have written one for loop up to minimum of n and m, and in this, if I have compared, if v1k is greater than equal to v2k, then sum equal to sum plus v2k, and else sum equal to sum plus v1k, and we will print the sum. So if you have any doubt, you can ask in the comment section. We will try to solve your doubt.